Okay, for section 7.3, when we have probabilities describing some things, in order to have a valid probability distribution, then when I add up each of the possibilities, the probability has to add up to be 1. Otherwise, somebody's cheating, right? So, for example, tossing a coin, there's a 50% chance coming up ahead, a 50% chance of tail, which means the probability of a head or a tail, 50% is 100%. This is going to be very useful in the section 7.4. And what this is saying is, if suppose I have an event E, and I have its complement, which is everything outside of it, then the probability of this guy plus this guy better add up to be 1. If, excuse me, if the sets are disjoint, and this is the only things that can happen, right? For example, like heads or tails, then when I add up the probabilities of these two, okay, let me back up for a second. If I have a universal set, okay, so we may have 20% here, 30% here, and 50% here. So when they're disjoint, you just calculate, when you take the union, you just calculate the probability of this one and this one by itself. In general, if these two things overlap, this is not true. You are double counting. So this situation is only when two sets are disjoint. Now, you'll remember from chapter 6, we talked about the inclusion-exclusion principle. And remember, when I add up the two probabilities, there was double counting. Remember with the Venn diagrams, you had to be very careful. So we found out that when I calculate the number in the union and the number in the intersection, that adds up to these two guys. But the number is bigger. So if you had 100 students altogether, this side and this side might be 110. And it was because you were double counting. Okay, let's take an example. Product reliability. Suppose a company finds from the service centers that 3% of their TVs that they sell have video problems. That is 3% is 0.03. 1% have audio problems, means 0.01, and 0.1% have both problems. Which, remember, you have to move the decimal place over two places, okay? So let's think about this. What is the universal set? It's all the TVs that they produce, some of which have problems with videos, some have audio, and some have both. So there's going to be an intersection. So if I take the universal sets here, is all the TVs. V is the one that has what? Problems with the video. A has problems with audio. And there are some that have problems with both. Correct? So now be careful. 3% and 0.1%. So you have to take what? The overlap and subtract it from the 3% and get what? 0.029. Also, the ones with the audio, was this set right here. We're told that was 1%. So you have to take the 0.1% and subtract it from this guy. In which case you could figure out how many are what? Okay, don't have problems. So if I want to say, what's the probability of having a video problem or an audio problem, you have to add up these numbers, not these two guys. These three numbers. So if I add up those, I get a what? Close to 4% that somebody's got a problem. What's the probability that there's no problems? It's everybody out here. This is very important. So if I know that this is 0.039, TVs are neither created nor destroyed. So I have to take this and subtract it from 1, which means what? 96.1 plasma TVs have no problems. So that gives you some idea on the quality control of your process.